Okay, everybody, welcome back to the iPhone class. And today we have, today's kind of interesting. I found some really cool lecture sets that are not in a PowerPoint, they're in a PDF format, but they work just the same. And it goes through a lot of formal introduction to things that I've already covered and some new things that I haven't covered yet. But I like the way that these slides are putting it together. So I decided to introduce to you today vocabulary. So talk about controls, views, actions, and some basic GUI components, list box and things that we've actually kind of seen already, but giving you the formal vocabulary that's associated with all of the information. So no hands-on stuff today, all vocabulary. And so in terms of the objectives, the first part here is to go over the UI control, UI labels, IB outlets, UI buttons, IB actions, interface builder. Well, we've already seen an interface builder, but there's actually an interesting activity as well. And each one of these, I've got about 4 of these different slide sets, and they're by Cgpoint Corporation, actually, and they're put out as open source so that people can use them to, I don't know, learn about the iPhone, but also in classes and things of that nature to sort of explain concepts. And I sort of picked and chose the ones I thought might be relevant for this particular class in terms of what we've covered. So to formally put the UI controls into perspective, what we're looking at is we've seen the interface builder, and we've seen dragging things from the library and putting them onto a window, and we've seen connecting them together using, using the little button control, essentially, or what do you call it, the drag and the drop, the outlet, IB outlet. So what we're looking at in terms of the base classes themselves for controls are going to be buttons, text fields, labels, things that you'd find on a form, which is kind of interesting. The way that the Android development separates it out is they put it into these categories. iPhone actually has them in categories, but you have to search on them through the library in order to get to the categories. And there's a couple of screenshots here in this lecture set that kind of show you that as well. So the basic classes for the controls are the buttons, text fields, etc. So in terms of the UI control, what we're looking at is the UI responder and then NSObject, because everything gets inherited from NSObject. So getting and setting control states is one of the things that we're doing programmatically throughout the process. And then setting the target action mechanism as well, preparing action messages, sending it to the target in terms of that functionality is also part of what we're doing for most of the controls. So when selecting the controls themselves, what we're really referring to is the actual view of the item. So actually a UI view that's associated with it. So UI buttons, and this is why they're using and like I was mentioning earlier, this is a vocabulary lecture essentially today, giving you the formal vocabulary for everything. The UI button, the UI text field, why they decided to put UI in front of everything, which is kind of an interesting question to ponder. It makes it unique for the API, but it also kind of emphasizes the point that it's a view. So it's a user interface view component, which is different from the control component that's next to it, or that works with it, or the logic. So the UI button, the text field, the segmented control, the switch, the slider, there's many other ones as well, and it makes no sense to kind of go through an entire list of them, rather showing you where to get them from. And we've seen this already in terms of the library, and this is actually an older screenshot, and it's still here actually. If you go from the interface builder, if you click on the tools and then go to the library, which we've done in a couple of examples so far, you can actually get to the objects by the categories. And the categories, and what you're looking at, the screenshot here, says inputs and values in here. And if you see the inputs and values here, I'll zoom in a little bit so you can kind of see what that says. You're looking at subcategories of text boxes, rounded rectangles and stuff. Or you could actually search. If you don't want to go through these categories with Coca Touch plugins, you can actually search on the items individually. But they're organized in terms of controllers, data views, inputs, values, and windows, different types of windows, status bars. And then you have your whole entire category of custom objects as well. And this is just for the Mac development. Actually, this is the Coca Touch plugin screen is what you're looking at. But you can actually get to that. Oh, this is interesting. I'm going to get back to the regular old view. Oh, there it is. Okay. No, that's smaller than it was before. Hold on a second. How did I mess up my view? Well, that's. I didn't know it goes. I didn't know it went really small. Let's go bigger. Oh wow, that's all right. Let's whoa. This is an adventure in really weird UI control, huh? All right, I'm gonna close this window and bring it back up again because I don't know how to get out of there. Okay, that looks much better. Okay. Wow. Okay. Actually, I wonder if this is the same one I was on before. This is the controls. All right, this is the screen I was on before. That was interesting. I didn't know you could do that inside of the PDF viewer. Apparently, there's controls I normally use for zooming outside of the interface, but there's inside the PDF viewer, there's actually more controls for zooming. And somehow I tapped into the PDF controls. Alright, so if you don't go into the library and use the categories, you can go ahead and search on the particular items if you wanted to. In terms of the label, this is one of the most commonly used items because this is where you're going to put information onto the screen. The UI label is part of the UI view, UI responder, and NS object. Noting that the UI label is not really a control, it's more of an output. So it's not really used for control. However, you can put and change the UI label programmatically throughout the life of the program. You can change the contents of that label at any time. So we're going to cover it with the controls because it's used with controls, essentially. So the UI label has text properties that are associated with it, and it's really kind of the basis of all of the other controls. So if I don't hit a particular control, you can know that the properties are going to be essentially labeled in a very similar kind of format to it. You know, for example, the NS string, which is going to be the text, is in the form of a, and this is the data type, the NS string, which is part of Objective-C essentially in terms of the language. And it's just like a regular old C string. And it's going to be the text property. So if you want, you know, .text, you get to that. It'll also the UI color, and the UI color is actually a set of built-in colors that are predefined and associated for properties. So you can set the text color to blue, to red, to orange. In terms of predefined colors, the alignment itself, the line break mode, whether there's a line break underneath the label, or whether or not the label is flush at the end. The UI, the font. And again, stored in a predetermined set of library format, do we have the UI fonts. And they're usually pulled from the font libraries, and people can upgrade those libraries actually. The only problem is you actually have to ship it with the font if you're going to use a special font that's not supported. So most people just go with standard fonts. Other properties exist as well. This is not, I'm not going to go through, I'd bore you to death go through each one of the properties, but it just kind of gives you an example of what's most popularly set. So most of these are set using the interface builder, but you can also set them programmatically. So as an example, a demo, you can put a UI label on a view, and don't worry about these phone images changing. They're all the same on each one of these slides. So if I were going to rewrite the slide set, I would actually change this and make it like, you know, represent what's being talked about, but that would be a lot of editing. So you would add the UI label to the interface, so the @interface component, and then you would add the UI label to the @property using the IB outlet. And we've seen that programmatically before, and we can automate it by dragging, essentially. You would add the @synthesize to the @implementation. You'd start the interface builder, drag the UI label onto the view. Control click or control drag click, actually now it's just dragging, there's no more control. You don't actually have to press the control anymore. You just click on the element in the IB outlet and just drag it over and you see an arrow and it attaches it automatically. And that's the connection part. So it's the UI label in the interface builder to the UI label in the code, which is actually being connected. So again, that's the formal definition and the descriptions of the components we've actually looked at already to a certain point. So adding a UI label and an IB outlet in the interface alerting users, let's say we have an interface alerting users view controller, where we can have a UI view controller with an UI alert view delegate, which we would add a special alert or notification to a user through the same type of control. So the UI label could be called a static label, or, excuse me, a status label, where we could stick it on there. And then we have a property and IB outlet that would talk to the static label, status label. So we implement the, in the implementation, so we add the @synthesize. So we can @synthesize the status label. At the implementation, we have the alerting users view controller. So it does fall in through to the model view controller kind of concept. And here's kind of like what it would look like if you're lost with the vocabulary so far. The IB outlet lets you connect the file owner to the label, and you can control click on the file owner to see the choices. This is usually part of a box that usually shows up on the right hand side. It usually has objects in it, and the objects are the classes, and here we have the first responder and the file owner. We have the different views and the different components that we've selected for this particular project that end up in this box. And the box is actually the XIB file that's part of the project. So when we go into the interface builder, that XIB file actually opens up and becomes this kind of a GUI. And this is not the icon view, this is the list view. By default, normally you've seen this in the icon view so far. But what we're looking at in terms of the view is, this is what was basically, given in the previous couple of slides there. The components for the UI alert, the UI action sheet, the label, which is why this is circled. This is the label that we're referring to in terms of the status update. And so you're control clicking on the file owner itself, and here's where the status label from a programmable point of view. If the other screen was up, you would drag it over, connect the item, which is the automated way of doing it. In fact, it's the only way of doing it right now. It's the way that you would connect the interface builder GUI components with the actual implementation of those methods for the functionality, the activities. And here's sort of like what it looks like. You'd take the label and drag it over. This is a blue line with an arrow, and this would highlight, and a little box goes around it, and then it establishes the connection. So the connect UI label to the interface builder to the UI label in your code, you would establish it through dragging and dropping, essentially. And if this doesn't work, this generally means there's a problem. If the items don't show up, this is the other interesting thing, if the outlets are missing, but you've put them in the code programmatically, it means there's an error. It doesn't compile correctly. Because it pre-compiles the outlet code, and it makes those object functionality available if it's functional. If it's not functional, you got an error in it, it doesn't show up in the window. So that's one of the biggest problems with troubleshooting this type of control, this type of connection to the control, is that you have no way of knowing if it's successful. But if you don't see it in the box, you know it's not successful. So it's like you have to almost experiment with it in order to make sure that it works. So, and until you connect it, you don't really even know if the code's going to work anyway, because you can't really test it. So the result of the control click drag, what you're getting from the previous, by dragging it over and establishing the connection between the IB outlet and the actual GUI component, is you're getting that the IB outlet UI label, status label, is connected to the UI label as used in the interface builder. And the connection allows it to say, on this behavioral change, on this label, do this. So, which is basically how you're connecting the activities and the functionality with the GUI. So when you set the status label property, the result of this are shown in the UI label defined by the interface builder. So self.statuslabel.text is equal to @itworks would set the text essentially to it works in the particular label that it was shown. So in terms of the UI label, if you created a UI label, my label, had an interface, at interface, had a property for an IB outlet as an example. In the at implementation, you included an at synthesize for my label, and then in the interface builder, you opened it up, the file owner, or you control clicked on something. Control click, or actually you can just use the mouse to drag and drop. You no longer need to actually do a control click. Connect the items themselves, and then you establish the connection, which is sort of the process of establishing that connection. In terms of the button functionality, it's done in a very similar fashion. It's technically called a UI button. It comes from UI control, UI responder, from NSObject. And what you're looking at is the inheritance route. Everything comes from NSObject. So this is where the object sits in the inheritance line, and everybody comes from UI control, which is what all the items I'm talking about today are coming from UI control. So in terms of the content, we have a display button. We have an interpret a touch event. That might be a button functionality. We can send action messages from a touch to a target object. We can use Interface Builder to position those buttons. So we use the IB action in your source code to connect the functionality with the button. So in terms of a demo of how you would put this together, you can put a UI button on a view. And so you add the UI button to the interface with an IB button, or IB action, excuse me, and then add the IB action to the implementation, to the add implementation file section. And then the startup interface builder, start it up, drag the button into the view. Same process as we did with the label. We would drag the IB outlet, excuse me, at this point the IB action to the GUI component to establish the connection between the two to give you the connectivity for the IB button touch up event for the IB code action. And what we can look at is, a long touch, a short touch event, a double tap event, all sorts of different events, and I'll show you that in a few minutes. But for how you can actually control the button and all of the actions that could occur, and you can attach a particular activity to a particular button characteristic in terms of how it's being used. So to add the IB button and the IB action in the at interface, learning users view controller, if we were using the same application demo as in the previous example with the label, we could add to the UI view controller this UI alert view delegate, the IB button. That's going to be a alert button. It's going to be the name of it. And then we simply do the do alert button, or from the UI button, and once it gets it, process the information that occurs from the message that's received from the button and process the correct action associated with it. So adding the do alert button, which is what we specified here. This is the do alert button that's going to be part of the IB action. In terms of that implementation, as the at implementation is where we're going to put it, alerting user view controller, which is the same example that we've been using so far with the label. IB action, do alert button, get the information from the IB action, the button, and then set the, as an example, self.statuslabel.text is equal to the button was touched. And essentially what you're doing is setting the at to a button was touched in terms of the text that's going to show up in terms of the status label that we put. So this example actually kind of works with the previous one in terms of the label. In fact, you can cut and paste and put all the examples together, and it all works actually in terms of a source code example. In terms of the interface builder to place the button, we have the label from the previous example. We're going to put it in the same file owner, so the IB action lets you connect the file owner to the button. And then same as before, dragging and clicking and dragging essentially, and letting go to form the connection on the button. So we can process that connection. And here's that control. So on our button, we've got our do action sheet button and our do alert button, two different buttons that were created. One of them might be a rounded rectangular, and we have a touch upside, touch the upside inside, touch up inside the button. So, or the touch up inside on the rounded rectangular from the UI alert, which is same kind of button, same kind of action, but we have two different received actions that are going to happen with two different events from two different buttons that are set that have been programmatically declared in that previous example. And here's an example of what I was talking about before in terms of touch cancel, touch down request, touch drag, enter, all this different things you can do with your finger on that button, essentially. Most people would probably just do the on touch, touch down. Touch down is the actual selection. You touch down on the button. Editing did end, editing did begin. I don't know. Probably just going to worry about the touch up outside. So you touched up above or outside of the button, and also the touch down perhaps. So it connects the UI button to the interface builder to the IB action in your code, essentially. So in summary, what we looked at in this particular lecture was the UI control, the label, the IB outlet, the button with the IB action. So the label's got the outlet or the output, I'll call it that way. The button's got the action that's associated with it, so IB action. And IB action stands for Interface Builder. UI is from User Interface Component. So why they use this terminology consistently, it's probably not a bad idea. Why they added it in, I have no idea. So IB is the Interface Builder. The control click, no longer a need to actually press the control key. Just the mouse will actually activate it all, dragging it to the target control. As a lab exercise, you could essentially write this view-based app by following through in the previous example. All the source code that is in the slide set actually are all the pieces that you would need for this. What it does is when you click a button, it says a button was clicked, and then the label changes, the status label changes on the other button clicking. So you can use the interface builder to place a label and a button on a view, add the code so that when you press the button, the text changes. The button was pressed. The text on the button actually changes to the button was pressed, and then build and show your results, essentially. It has a solution, and you can cut and paste, and I'll make these slide sets available, these PDFs available as well. They're open source lecture material from the Android community that essentially, from iPhone development community that actually makes really good. You know, they're very low-level examples, but it gives you the vocabulary that showing real source code doesn't actually give you, in the most part. So in terms of the contents of this lab, if you were to create a view controller, it would be the lab viewcontroller.h file that would have the template as we know so far, and we've seen this part before, at the interface, creating the label, creating the button, the properties for the IB outlet, and the label themselves for the actions, for the UI button and for the IB action. And then in the .m, we're doing the implementation. It's going to be the source code here that sets the button, that the button was pressed. So the self lab label.text with the label on the button, make sure it's checked. And then remember to use the interface builder to connect the IB outlet and the IB action. And then you've got a working application, essentially. Alright, so that was the first part. The second part of today's kind of review, and what if you came in a little late, what I'm doing today is giving you some vocabulary that goes along with a lot of, and giving you the formal kind of textbook explanation of some of the things we've seen so far in terms of GUI components to wrap up the interface builder and the GUI part of it. And then next week we'll start in with something different. Notification. These slide sets actually come from Servin, which is a trademark for Servin Corporation. So to give proper credit to where credit is due. So in terms of the objectives of this particular lecture, looking at the concept of tables, we've actually seen this, and we've seen, well, we saw it in one sample application I showed you right in the beginning. So looking at the table view controller, the table view cell, the table view data source, and the view delegate, and then again coming through a little bit of an example to kind of give you the lowdown of putting it together. So that's a table, red, green, blue, table of colors. So we can have a control button here, we can go back to the table of colors. So if we pressed on red as an example, we pressed on the button here, and it would take us to the screen here, it would show us a red screen, and then we would click on this button here, so go back to table of colors, get us back to our table. So what we saw this in was the bug program. So we saw bugs that were loaded in a list view / table as a concept, as a UI. In fact, one of the things that this lecture actually does a nice job of doing is it goes through some of the layering, the nesting of components. So putting components inside of other components to create some GUI effects in terms of the functionality. So the table view controller is coming from, this is the hierarchy, the table view controller comes from the UI view controller, which is coming from UI responder, which is coming from NSObject. So we're still coming from NSObject, essentially. We're just going to have different levels when it comes out past the responder UI. Well, actually, UI view controller is having, it's probably the common part where most of the GUI starts coming out of. So it manages a UI table view, and a table view is what we use for those bugs, actually. So it manages the data source and the delegate for the UI table view. So key properties of this, well, we have the table view, the UI table view, and from the table view, so we've got the table view controller that has a table view. The table view, again coming from table view scroll view, from UI view, from responder, from NSObject, displays a single column of information. So the single column is where we're getting the table from, and it displays sections of multiple sections of the table. So multiple different sections, such that each section is in the UI table view cell, which is a lower level hierarchy. So think of this sort of like a hierarchy of components that all work together to give us the table view. Requires a data source and a delegate. Typically we use a UI table view controller that has a table view. So in terms of the properties, we have ID UI table view data source, which would be our data source declaration, and then our ID table view delegate, or delegate, and then we might have other ones that we might set in terms of properties. Noting that the data source and the delegate typically handled by the table view controller. So we'll see this in an example actually coming up just the same way as we saw the label and the button a few minutes ago. So the table view data source protocol, we've got NS integer as our data type with number of sections in the table view. So it's going to give us our number of rows, or sections I should say, not necessarily rows. The table view itself is a table view, is a component. Another NS integer for the table view, which is going to give us a number of rows, or our implementation essentially, and our section. So we've got the table view, the number of sections in the table view, the number of rows in the section, and then we have the cell for each one of the rows at the index path, or the location inside. So think of it sort of as a nested hierarchy. So the Delegate protocol, so inside of the table view, the UI table view, we did a select row at index path. So we're going to find a row given the index path dot row, so we can know which row inside of which view, inside of which controller we're actually interested in. And how we would actually put this one together, and this is where hopefully it's going to make more sense to you in terms of putting the vocabulary into the programming concept. Start up an Xcode project. Click on the navigation-based application for this type of project because we're looking at the UI controllers. So it's definitely a view controller application that we're going to create. So we're going to need the navigation-based, which is going to give us our templates. Or it's going to give us our objects that are associated with the navigation in terms of our project type. In fact, we did this for the bugs, actually, for the bugs list, or scary bugs. So by default, we get the root view controller, the .h's and the .m's, and we also get the color, table color app delegates, the .h's and the .m's. It's kind of hard to see that, but these are what we're looking at in terms of the template. This is just the generic setup that we're going to get. The key files, and here they are here. This is what we couldn't read on the previous slide, but the root view controller .h, root view controller .m, and the root view controller .xib for the interface builder. In terms of the root view controller XIB, we can create, this is a table view that was created, and the table view we put in cities in California, or actually California's a state, but in California we have Cupertino, Glendale, we have different cities that are in the state of California, which is kind of an interesting table view. I mean, it's a typical, just like the bug list, except for in the bug list we actually put images in the particular table that we saw. But the same concept as before, you're picking the root objects from file owner, and you're essentially adding things into the table view. In terms of what the root view controller.h file looks like, in terms of the specification here, we have an import the UI kit, UIKit.h, and then we have the interface for the root view controller, UI table view controller, to overload that, NS array for color names, a property as an example for the monatomic retain for the color name to get the set and get the color name essentially of each one of the and this is from the beginning example where we had red, white, blue. We actually set the background color. When you press on the color, it actually sets the background color of the window. So in terms of the .m implementation, we're importing the .h, we're importing the table of colors app delegate, because we need that table of colors to go with it, so we can basically call a table from the table of colors one of the colors to put in the table view. And we're running synthesized color names, and we're going to view a did load. Which one did we load? Super view did load. And so we have the title set as a table of colors. The color names will set up an array, and the objects are going to be red, green, whatever it is, whatever happens to be what we're going to set. And this is going to turn up being the objects that are going to show up on each one of the rows in the table view. So to continue with this, the number of sections in the row view, to get at that, we can come out with a number that's associated with the number of sections we have actually in there. So we can tell when the user has selected all of them or something, or the last one or the first one. So also the number of rows in each one of the sections. In terms of the implementation, setting the self color name count, so we can keep track of the number of colors that are actually in the view itself. And so in terms of the continuation along the lines of the implementation of this, the table view itself, the self for each one of the rows at each one of the index paths, we can set the rows from the inside of each one of the cells. So the cell is going to be equal to table view DQ reuse some cell identifier with some sort of a cell identifier that we're going to set. It's just so we can get at the various different components. I mean, the reason why we want to get the different components is because what if we want to return back to it after something was selected? Or what if we want to control how many items are listed in the table view? Or what if we want to change one programmatically? So it allows us a little bit more flexibility in terms of the establishment of that stuff. So if the cell is equal to nil, then the cell is going to be equal to table view allocate it. So with the internet frame, init with frame, CG rectangle 0, get it the identifier for it, auto release it, which means allocate the color for the particular item that's going to be in the table view. And this is sort of the tail end of it in terms of the setting up another variable for the index, which is going to be the index path row, and then setting up the text, which is going to be the name of the color. So the color name is going to be showing on the text view. If you can imagine that first slide I showed you with the, I can't remember the name of the colors. Red was one of them. Red, green, and something or other, which is basically the label that's showing up in the text view. In the table view. Here it is here, actually, if I had just gone another page forward. So this is the table view itself with the title table of colors with red, green, and blue, essentially. Then when you click on it, you actually get to see the cell that's inside of it, which is nothing more than a green background or a red background. So the table view itself, you can get a did select row at index. Is it selected? If it is, then control the activity. So we have the view controller, that's going to allocate the activity in terms of opening up the particular cell, showing you the contents of it, which is nothing going to be nothing more than a painted background, essentially a colored background. So using the UI view, you're allocating a new frame for it. You're allocating the screen opens up, and it shows you the color that's been selected. Switching between the different views depends upon the index path .row that was selected. So depending upon which one is selected, case 0, my view background is going to be equal to, I think it was red, then it's going to go to green, then it's going to go to blue. And this is essentially the case switch concept in terms of figuring out which row is actually clicked on, because you're not going to create a new screen for each one. And you're going to use one screen, you're going to paint the background color to the matching color of what was on the table, essentially, that was selected. But this is a good example of the get index or the index path.row using that information, which is what you're going to get. So what this example is doing is this is running through all the different components of the table view and the controller for it, table controller. So self-navigating controller, push the view controller, my VC animation would be set to yes, which means it would open up the new, the screen would go to the left, slide away to the left, and the other screen would show up with the color of the background set correctly. So, and then release the memory for it. So what you just saw was kind of a rundown on the table view controller, along with the table view cell, the table view data source, and the table view delegate, which all works together to provide you that functionality that we just looked at. And the latter part of this is putting all of those pieces together, just like the first example that I gave you, to recreate the navigation-based app that was kind of given to you during this presentation. So what I'll do is I'll make the slide set available, and I'm not going to go through this because going through it is actually not going to really, in fact, the slide set doesn't even go through it. It's not necessarily going to show you anything, but you could actually run through the different steps, cut and paste the code segments, put them in the bodies of the .ns and the .h's, and actually kind of get the table view to work. The other choice you have is actually to go back and take a look at the bugs. The Scary Bugs program. Scary Bugs program does the same thing, except for it actually puts an image in the table view along with a title, and it sends you to another screen from each one of the entries. So the other topic I kind of wanted to talk about today, and today is kind of I call it sort of like house cleaning day. I've got subtopics that I've shown you in examples, but I haven't given you any like lecture formal vocabulary on. Alerting users, which is another kind of interesting way of sending out information. So sending out a UI alert view, which works along with a UI view delegate, action sheet delegates. So it's kind of an easier concept. We haven't actually seen this programmatically, so what I'll do next week is bring in an example of a project that uses an alert message so you can sort of see it, which is kind of easy actually. In fact, it's just about as easy as on the Android platform as it is on the iPhone one. So displaying an alert message, the delegate, if used, must implement an alert view delegate protocol, which means it's going to be an alert. What will an alert do? Well, it just notifies the user that something happened. So you can kind of make up your own alerts actually. What are they? They're just going to be string messages. It's kind of like sending out a toast message on an Android phone. So the UI alert, allocate an alert with the title, whatever title we're going to set, and it's going to be the data type an NS string, and we're going to have a message that's going to be associated with it. It's also going to be an NS string type. We're going to use a delegate ID delegate, so we have an ID associated with it, and we might have a cancel button on there. It just says cancel, or other buttons with a title 1, 2, 3, 4. So if you've ever seen compared to an alert on a Android phone, this is a little bit more, more features associated with these types of alerts. So it's a window that's going to come up, kind of like a dialog box. It's going to say, "Network failed. Would you like to retry or cancel?" retry without this, retry with this, or give you some options essentially. So the delegate can be nil. You don't have to actually use it, and you can terminate other button titles list with a nil if you want to. So the alert view delegate implementing this method to handle the alert button press, which is similar to the IB button action. So it's going to be a UI alert button press. So the alert view clicked button at index. So it knows which button you clicked in terms of the index of the buttons that you've set on the alert dialog. And here's an example of what I've been talking about. I won't try to zoom in on this because last time I tried to zoom, I had to restart it. But we have a alert window, and I'm sure you've seen these before, that pop up occasionally on the iPhone. It says, here's your title, here's your message. This is from the code actually that you saw in the previous slides that it didn't really go through very much, but we have a no, a yes, and a maybe. So we have 3 different options. It might be, would you like to quit this program? No, yes, maybe. And it came from this UI alert button, so we pressed the button, it generated the alerts essentially. The alert could have come from something else. We just needed some sort of an event to generate the alert. So here's how this program actually got put together. And there's a UI label, a status label that showed up. There's a property going to be for the IB outlet, which is essentially the same thing we saw before in the other example, where we just put a label out here, or put a label out here that's going to say, which button was pressed. Put a button out there, a rounded rectangular button that looks like when we press it, there's going to be an action associated with it. The action is going to bring up the alert box. So do alert button, which is going to be our IB action on our button. So we are going to be able to change our UI label. So this builds on the other first example I gave you with the label on the button to work with the action. So the IB action do alert button. So on the UI button, we're putting the IB action to do the alert activity that's associated with it. And we're going to allocate, we're going to say the title goes here, this is where the title is, this is the text that actually appeared in the alert box. It said title message here, title and message from the alert box itself. And it's setting in the properties, so init with title, init with the message. So the message is this dot, delegate self cancel button title. So cancel button title is going to be no, and the cancel button title just takes the message, the alert message away, just cancels it. The other button titles is going to be yes, comma, maybe, comma, nil, which means there's no more. That's the end of the list. So we have 2 additional buttons, the one for yes and one for maybe, that showed up on the screen. And then we have the implementation of the code for the button. So the click button at index is going to take, and at that particular index, do something with it. We go through a series of, well, if it's yes, it's going to do, I have no idea what it's going to do for yes, no, and maybe, but it'll do some activity that's associated with yes, no, and maybe. Or actually, one of them is a cancel, probably yes is canceled. No and maybe have other options associated with them. So create a string. And on the button for the string, we're going to set the label. So the label that we've got set up, we're going to put on the label the dot text is going to be S, and S is going to be, well, what button was pressed, what index. So was button index, get D for the button number that's going to show up out of the index when we go ahead and run that method. So in terms of a summary of this particular content, what we're looking at is the, allocating the memory for the UI alert view, looking in terms of the init with title, setting the message, setting the delegate, setting the cancel button title, setting the other button titles, showing it, actually displaying the alert, and then functioning the UI alert view delegate. And then the on-click, or the clicked button at index activity that's going to occur on the activity view. So in terms of the action sheet versus the alert, similar in function to the UI alert view, different in appearance. So the action sheet, you're allocating it the same way, in a very similar way. You've got a title that you're setting. You have a delegate to set to self, but you can set the delegate. The cancel button title, cancel. The destruction button title, destructive. Other button titles set to 1, 2, 3. And as shown in the view, here's the sheet where we've got slightly different appearance than the alerts. It's a little bit bigger, a little bit more functionality associated with it. Where we've got buttons with cancel on the bottom, which is different than it's a different style is what this is actually, but very similar in functionality. So it's the same concept as before. There's going to be a label. Here's the label. There's going to be a button. You press the button, the sheet comes up. The sheet's essentially not looking like a dialog overlay. It's in a separate window that's on top of the window. It's a slightly different appearance. So in terms of the code example, using the UI action sheet delegate and setting the IB action to do an action sheet button. On the action sheet button, we're going to set particular activity that's going to occur, action that's going to occur upon a press of the button. In each one of the buttons, we have like 4 or 5 different selections that we can do. So do action sheet button, where we're going to set cancel button information, the title information of the button itself, destructive button title, other button information, and same concept as before. We're going to get the index of the button that was actually pressed and use it to update the status of the button press that's going to be placed on a label. So status label.text, which is that label that appeared above the sheet, above the button actually. That's going to show us what button was pressed when we do it. So in terms of the summary, as you can see, it's kind of very similar to the alert as well. So you can use it with the delegate, the cancel button title, the destructive button title. It's just basically going to take it away, destroy the sheet. Other button titles can be added to it. You can display the show in view, which view you're going to show the sheet in. The action sheet delegate, and from the action sheet delegate, the clicked button at index activity that's going to occur for each one of the buttons that were pressed at each one of the index values from the sheet. It's very event-driven in terms of, well, it is event-driven in terms of button clicks. So in summary, what this kind of demoed was the alert view delegate, the action sheet delegate, which are very similar concepts. In terms of the lab exercise that goes along with this, you can create a view-based iPhone app where you're going to implement the 2 screenshots using the code actually that's given to you in the particular PDF file. It will actually compile and run. So in the view did load, display the UI alert view and display the UI action sheet. And you might observe some different behavior between the 2 of them. You don't have to actually do this lab exercise. This is just one of the recommended learning outcomes if you're interested in taking it a little bit further. But in terms of the solution, the guidelines are kind of walking you through it. Create a view, from file, new project, view-based app. Refer to previous slides for the code. Actually, the code's all given to you for it. In fact, if you just cut to paste the code in to the main activity that's occurring, it'll actually load it up, and it's all outside of connecting the button actions, the IB buttons to the code itself, it actually will work just fine. Alright, the last part of this for today is device information. Getting the device information from the particular phone. And this I'm going to kind of skip through just to let you know what's available. And I'll make these slide sets available so that you can go download them and cut and paste and work through the activities if you're interested in performing some of the exercises that are here. But looking at the UI screen, the CG rectangle, Cgpoint, CG size, rectangle make, rectangle zero, looking at from a lower level graphic capabilities of the device itself, from the UI device, and screen features. So it's basically on device features in terms of status and things of that nature. So the UI screen returns information about the screen, methods for the main screen, properties for application frame, for bounds. So you can resize the screen if you wanted to in terms of the bounds of the way that the application is running. So UI screen main screen returns the screen object, so you know what's on the screen. So if you're trying to control the activity of what's going on, something is on the screen and you want to know if something's on the screen. You can detect that from the device information that's available to you. So main screen UI screen, where it's going to be equal to the main screen, it's going to return that object and let you know, so you can work with that object from programmatically capabilities. So the UI bounds property and returns the binding rectangle of the screen. So, or actually of components that are on the screen. So CGI rect bounds. There's an example on the next slide, but the screen bounds or dot bounds is going to give you the dimensions, so the location and dimensions of the rectangle. So you can specify areas of the screen in terms of the bounds. And here's an example of a rectangle which has a Cgpoint origin and a Cg size. So you can actually kind of set, and this is C code actually, well, Objective-C, but it's C compatible as well. It's a structure for which you can actually kind of declare a region on the screen. So, and you can call this, in fact this was going to be called rectangle, CGRec actually, in terms of its definition. It's nothing more than keeping track of the origin and the size of a rectangle. And it's a call that you can actually do to kind of say, well, where on the screen, where is the rectangle? And you can move the bounds. So you can resize an application window, overlay a window on top of another window. I don't know, use the information for a lot of different uses. Cgpoint defines a point on the screen. So a point on a two-dimensional space XY, regular point. So a structure Cgpoint here with float X and float Y. So we would use create an object Cgpoint from Cgpoint. This is a structure that we created. And it's just nothing more than being able to look at a point on a particular screen. What that would be good for would be some specialized touch control or something. See what point did the user actually touch on the screen or something. Or was something touched, and if so, what region or what point. Or defining different areas of the screen. CG size is going to be the height and the width values. So you can come up with a structure here, CG size, as an example, with the width and the height, and you can make an instance of that particular structure. And, define the height and width. So resize something. Rectangle make and rectangle 0. That's a rectangle make where we've got a float X, a float a point, a width with a width and a height to actually make a rectangle 0 out of this. So we can have a CG rectangle 0 that we can create, or we can create a rectangle using a given point and a height and a width from the point. So kind of draw our own graphics essentially. And it actually supports OpenGL as well, but this is a little different in terms of getting at the screen information and the device information so that you can apply that with another API or with an application to do something in particular that you're interested in accomplishing. So, unless you have something to accomplish with this, it's really hard to kind of conceptualize why would you even need to define a point on the screen, or why would you need to get a point from the screen. So frame rectangle for app use, so the bounds minus the status bar rectangle. So we can come up with the area in which the app is residing. And so we have the application frame as a concept. And here's an example of the screen would be equal to the UI screen, main screen, and then we would have a rectangle that would be equal to the screen dot application frame. So we're not looking at the status on the bottom, or the menu on the bottom, or status at the top, or anything. We just want to look at the application. So we can swap that out with something else or do something with it. So here's some code that's associated with the UI screen, a little code demo. View did load to see if something loaded. So we're checking a rectangle using the bounds that we've established for it. And we're kind of come up with a string, and the string is going to give us what's at this rectangle origin x, y with a height and a width. Kind of see, well, what's loaded? So what's on the screen? So here we have the UI bounds in pixels, where we're going from 320 to 480, which is essentially the dimensions of the particular screen. So might be nice to detect what's on there, or you know, write something to it, or do something from a screen perspective. So the UI bounds property origin is 0, 0. The size is 320 by 480, which is a basic video size actually. So if you're looking at video and you're trying to resize a video, that might come in handy actually to know that, to position it. So UI screen application frame property origin might be set at 0, 20, and the size might be 320 and by 460 because you have that little space on the bottom and you have a little space on the top. It might not necessarily go all the way to the left or all the way to the right. So, but this is the application frame property. So you use the application frame most of the time because you can't really use the entire screen unless, for example, you're gonna, you know, load a movie file or something like that. Then you're probably gonna occupy the whole screen. But you could move it over if you wanted to and leave something else visible on the screen. That would actually be a nice example of why you would use any of this stuff. So if you wanted to position your application over other parts of the screen, go over into areas where the application doesn't normally exist, or if you wanted to make the application smaller area on the screen or reposition it somehow, depending upon what you're doing. Might be a video file, might be an MP3 file or something. So in terms of the UI main screen, we looked at that, the bounds, the application frame, and the CG rectangle as concepts. So in terms of the UI device, we have a singleton object for device information, UI device, shared device. We have static information for the model, the system name, for all of the device information that is stored on it, dynamic information for the orientation. So is it landscape, is it portrait mode currently? Because we might be able to make our application not switch if we wanted to, or I don't know, detect that particular device information in terms of what angle. In terms of the UI device properties that are static, these don't change, they're always the same, we can't change them. We have the model, system name, system version, a few others that might go in there. It might be helpful, you know, because what version of the iPhone does somebody have? You know, what they have, how many cameras do they have on that thing? Or kind of can give you information in terms of troubleshooting problems, debugging, or setting parameters for applications. How big can you make that screen, or how small can you make it? I can see where you'd want to get at this frame size. Instantly you'd know whether or not you were working. Like if you had a universal app that worked on an iPad, hopefully it would, and an iPhone simultaneously, it was the same app, you could resize the GUI, change the GUI components depending upon the type of screen, or the frame, or the model, or the version of the device, depending upon what you had. In terms of the dynamic content, the orientation property changes, the device orientation changes, so, you know, it's left, it's right, excuse me, landscape, portrait mode, that's dynamic. So the UI orientation can be set, so we have different information we can get. The device orientation might be unknown, it might be portrait upside down, portrait landscape right, left, face up, face down. So depending upon all these things, we could change the activity that occurs during the app. Maybe the app just goes black or something if it's in the wrong mode. So we know we're not going to use it. In terms of the device methods, we can get the current device, start the orientation change, begin generating a device orientation notification. So we're going to switch you back to portrait mode. To end the orientation notification, get the generating device orientation notification. As an example here, begin generating a device orientation notification to, basically set the notification to change to landscape or change to portrait, depending upon what activity you're trying to perform on that particular device. Especially if your application only works. In fact, you probably have noticed this already before. Some applications that only work in landscape mode, it will, even though your phone is in portrait mode, it will open in landscape mode. It will change the orientation which is what you're going to do essentially. Well, this example is going to go through it, but you're going to change the orientation mode to whatever it is you want for that application that's going to open up. Otherwise, the application's not going to look right. Like, it only shows in landscape mode. And some videos and things like that might actually need that capability. So you can programmatically change the mode and send a notification. Essentially, the notification is going to initiate that change. We're changing from portrait to landscape left or landscape right or something. So the view did load. This is from the example in terms of the sample code for the example, one of the examples that comes with this. We have a label, a model label that's going to pick up the current device model, a name that's going to come up with a system name, the version, they'll be put in a version label. So the code runs when the orientation changes. It's going to switch, let's say the orientation, use a case where if it's portrait, we're going to change the label to I'm in portrait mode. So you can write a little app essentially that when you move it, I'm in portrait mode, I'm in landscape mode. So it basically, it's sort of like the hello world of device information. Let you know what's going on the device itself. So in summary, this is the last part of the lecture. I'm going to go over the assignments next. In terms of getting at the UI device, it is the current device, the model, the system name, system version, and the orientation is the information that most people find the most helpful in terms of getting device information. You need that because your application needs to auto-detect certain things in order to display itself well, or to recover from situations, or even know what it's running on in terms of the implementations. The UI screen, UI rectangle, the Cgpoint, CG size are all just different ways of using the attributes of the screen, the application view, the device itself. So this lab exercise is just going to go through what that I was just talking about a few minutes ago. Putting a label on the phone, so you move it on to the side and it'll say I'm in landscape mode or something. So we have screen values, device values, cutting and pasting, and here's a couple of examples. In terms of cutting and pasting some of the code segments and putting them in essentially to a project, compiling the project and seeing what would happen. Now, it's not going to work in a simulator. It's really hard to actually move a simulator. In fact, it's impossible to rotate the simulator on its side. So, are you going to turn your computer upside down? I don't believe, I've never tried it before, but I don't think you can do that with the simulator. So last time, I was made aware that the assignments were not on the website. So I found the assignments and I put them on the website. What I want to do is kind of go through them. They're quite easy. I also put together the CSLO essay. All of the assignments are due on May 1st. And as we just discussed before the class started, the final exam is going to be the last week of April. So around the last week of April, which is another month, 2 months. This is only the 3rd or 4th of March. So we have March through April, essentially. So what you're looking at on the screen right here is project number 1. Now again, all the assignments aren't due until March 1st. Excuse me, May 1st. May 1st, yes. So you're going to build a simple calculator program. I specifically left the features wide open. So if you want to do more, you can, but you don't have to. In building your simple calculator program for the iPhone, you're going to design an overall look and feel that is completely up to you. You can create a generic calculator or you can do a tip calculator. There's a ton of books that run through examples for tip calculators. I'm not quite sure why that's so popular, but maybe it's a very popular app to have for a phone. Because most people run into situations when they're in restaurants. So how much do we tip? Some people double the tax. I don't know. So you can type in the amounts, and it can give you some choices. Good service, bad service. Bad's no tip at all. I don't know. Or you could do, let's say, a mortgage calculator, or a car loan calculator, or just a generic calculator. It'd be nice to have like a really big calculator with really big buttons on it. So it's late at night, you can barely see your phone, but you can still use the calculator kind of thing, instead of some small buttons. Anyway, design your own calculator, any theme that you want. The theme is up to you. The calculator should be fully functional, which means it should do what it is your calculator is supposed to do. So that is, the user clicks on features. The features should produce the result that is appropriate for the functionality. Design your own user interface and your own functionality. So that's pretty easy, huh? It's pretty straightforward. So you can use any UI component that you want with any controller that you want. What to turn in? Your Xcode projects. I need your whole project. Actually, you could just take your project from your workspace directory or from your home directory where it's going to end up, and just zip the whole thing and post it to the EMS. So if I get your whole project folder, then I can actually see who did it in terms of the project properties and stuff. Make sure it's all unique among different students. Everyone needs to do their own work. Questions about the simple calculator program? And each one of these is probably going to take you, depending upon your comfort level, how long you've been experimenting, an hour to 3 or 4 hours to a day, depending upon your background. Tic-tac-toe game. Probably easier than the calculator. I don't know. This has got, multiple GUI components that are layered, or not layered. You've got a box, you've got a region. So you're going to determine the required components in operation for a 2-player mode game of tic-tac-toe. Using a window, create a suitable display grid, 3x3 buttons. Okay, so I can tell you right now the easiest way to do this is to put 3x3 buttons, actually use buttons. But you may not want to use buttons. You could change the properties of the buttons so they don't look like buttons. Or you could put labels in there, and the labels change from nothing to an X or to an O. Or you can have any design you want, actually. But you're going to have to figure out how you're going to do the UI design, and you're going to be having to control it, and then you're going to have to keep track of who wins and who loses, essentially, whether or not you have a tie. So the logic is a little bit probably easier. In fact, this program is probably easier than the tip calculator, but it requires more thinking in terms of the overall design. So let's see, as the user clicks on a button, the text should change to the letters X or O. You guys know how to play tic-tac-toe, right? If not, look it up on the internet. Tic-tac-toe, very popular game. You should know it. So, display should show the game statistics. Actually, I was in another class and I had a battleship program. Nobody knew what that was. It's like an old game from the States. So, but tic-tac-toe, you guys should know. Alright, so create a function to check to see if there's a winner and display the winner when there is one. And allow the users to play again, retaining the data for the wins, losses, and draws. You could have the user play the computer. You don't have to have a 2-player interactive game. You could have it because, if you're, let's say, bored, sitting in a dental office waiting for your appointment or something, you could play tic-tac-toe against the phone, maybe. So your other player could be a computer, but it's 2 players. It's you or somebody, and it's either a computer or another person playing. This is not a client-server program or a peer-to-peer program, or no threads, no inter-process communication going on here either. Pretend like it's all on one computer, and you're handing the phone to the other person, and the other person is pressing numbers on the same phone. You could make it a lot more complicated, but you don't have to. Questions about the tic-tac-toe game? And again, you want to zip up your Xcode project and submit it to the LMS by May 1st. Project number 3. They do get progressively harder, but not really. Not that hard. I made them all kind of easy. A clock application. Everybody wants a clock on their phone, right? You have a clock on your phone. You're creating a simple functioning clock on the iPhone. So you create a first program that includes a UI label showing a functional clock. So you've got a clock. Second, create a stopwatch program. So it should have 3 buttons: start, stop, and reset. Because once you have a functional clock, you know time. So now you can get at the time once you've got a clock running, and then you can, set the hours, minutes, and seconds, and have a stopwatch and record time. So the view, you guys are familiar with the concept of stopwatches, I assume, as well. The view should begin with a start button highlighted and enables the other buttons neither highlighted nor enabled. So you only can select start. You can't select stop unless you select start first or pause. Pressing start should start or restart the clock. So it's keeping time. Disable and unhighlight the start button and enable and highlight the stop button. So when you press start, stop becomes available. So you can press stop after you press start. Pressing stop should stop the clock. Display and unhighlighted the stop button and enable the highlighted and the stop button and reset buttons, whatever. Reset, stop gets rid of start. Or stop makes start highlighted. And stop is no longer highlighted. And reset is always highlighted, I guess, in that particular case. Anyway, play around with the button, highlighting, unhighlighting, whether it's selectable or not selectable kind of thing in terms of the logic. And what you're doing is creating a stopwatch program. Questions about the stopwatch program? All right. Number 4. After you've created your stopwatch program, in number 4, there's not too many left. There's only one more after this. It goes along with it. In fact, you can turn these guys in together if you want, but I highly recommend turning them in separate. That way, you turn the same program in twice, but make sure it's number 4 that you're putting in for number 3 and for number 4 space. That way I know you got the functionality working. Part 2 is extending the simple functioning clock for the iPhone. Or you can just turn it in 2 different parts. This is fine as well. Using the clock program you created in assignment number 3, create a timer program. You should have 1 start and stop button, 1 picker, and 1 clock. So the clock shows the days, hours, minutes, and seconds, and countdown. And the view should begin with the start and the picker. Use the picker, let's just see what that is, to set the amount of time to count down. 2 hours, 3 hours, 1 hour, 1 hour. Use the start button to set the clock with the desired time and to start the countdown. The labels should change to stop when the clock starts, and use the stop button to stop the clock and reset it to 0. Make your timer do something of your choice when the time's up. So take out the trash, or I don't know, it puts a toast message out there that says something. Hey, the timer stopped. So you can use the application number 3 as a base for this one and just add the functionality, add the features to it, or you can start fresh on a new program if you want. You don't have to use the same application. So this one is a timer/countdown timer program using a picker. So you're going to pick them from 1 hour, 2 hour, 3 hour, and you're going to use it to count down. So it doesn't have to do anything too spectacular. You could just put up a that's an Android message. So you don't want to put an Android message, a toast message out there. You're going to do something else. You could put out an alert window that says, hey, do you want to do this again? Do you want to cancel? Or just throw out a message notification or something, or do whatever you want, actually. You could be creative. And you can be very creative in the design of this application as well. Questions about part 2 of the clock application program, the countdown timer. So this one's a timer, the other one's a stopwatch. And you have to build a basic clock to work with both of them. You're going to love number 5, it's not too bad. No more clocks. But you can continue with the clock theme if you want. Last but not least, you're going to create a multi-view program of your choice. So create a program that involves multiple views. The main view should contain a grid of subviews which can animate and flip around to reveal the front and back views. I mean, if you have multiple views, you're going to switch between the views. The front and back views would be underneath the other views. You have views that overlap. The front and back views should be contained in a container view that sits above the root view. And we haven't actually talked about views yet. That's coming up. you can use any theme you want and create any type of program that you want, with any functionality that you want, that uses multiple views. If you want, you could just create screens that say, I'm view 1, I'm view 2, I'm view 3. Make them different colors or something. And then switch between the views. Maybe have a little menu, a context menu or something like that that says, hey, you know, view 1, view 2, view 3, view 4. You don't actually have to create a theme for this application. But if you want to, one of the most popular things to do is a card game. You know, like Solitaire or something, where you got views where the cards are upside down, you press the card and it turns right side up. You could easily make a Solitaire actually out of this. Or you can have, you know, Hangman, or I don't know, Wheel of Fortune, you know. Guess what's behind the views, and the views flip over and you see the whole thing, but you don't have too many layering views at that point. Or you could just simply not have a theme at all. Or this is your opportunity to design and implement an iPhone program, anything that you want as long as it uses multiple views and shows different views when the program runs and the program is being used. So the sky's the limit on this one. So in fact, you'll find that most of the sophisticated applications have multiple views. And I didn't actually say how many multiple views you needed. Multiple is usually 2 or more. So you don't have to come up with 10,000. If you have a Solitaire program, you're going to have, how many cards are there? 52 cards in a deck or so? You're going to have like 52 different views for each one of those different cards, probably. That's going to be complicated. If you want to do something a little simpler, you could just come up with my view program and make up different views and switch between the different views when the user clicks on something. Clicks on something and it opens up something else. Opens up something else. Questions about the multi-view program? With multi-view means more than 2, well, multiple, 2, at least 2 different views. Preferably 3 or more, but multiple is more than 1. So, last but not least, on the agenda for today is the lovely CSLO essay. All of those assignments are worth 50% of your grade for the course. Each one of the 5 assignments is worth 10 points each. The CSLO essay is worth 25 points. This is really a substitute for a midterm. The final exam is worth 25%. So 50 plus 25 plus 25 is 100% of your grade. CSLO essay is also due on May 1st, the last day of the class, along with the assignments. And this is going to be easy. It's going to be super easy. Because this does not involve any programming. This is writing an essay. And you get to pick one of these topics. And you're going to love topic number 9. It says select a topic of your choice that relates to iPhone application development and write an essay on that topic. If you don't like any of these other topics, you can pick option number 9. So total freedom on this. That's why I said this is going to be easy. You're all not going to be writing on the same topics, I assume. Some of you, hopefully, will be coming up with your own ideas. But you don't have to. You can pick one of these predefined topics. Predefined topics are kind of stupid, actually. They're kind of describe the basic concepts and techniques of developing applications for the iPhone and the iPad. It might be hard to come up with some information on that. I don't know. Explaining how to use the SDK and other development tools. Explaining how to program in Object-C. You could probably write a novel. You could probably write a textbook on Object-C. You don't have to do that. 2 to 3 pages, double-spaced, which is 1 or 2 pages, single-space. At least 3 reference citations, which means I want you to do some research. You can research the internet. There's a ton of information out there. There's a ton of PDF books and stuff like that, too, that are available for free on the internet. That aren't pirated. They're actually open source books. They're free. Write it yourself. Don't cut and paste information from the internet and put it in and say, hey, here's my paper. So write it yourself. Whether I'll put it through turnitin.com, I don't know yet. But just leave that open in terms of possibilities, but probably not. But in any case, I do want you to write it yourself and use your own writing. Use your own writing. Plus, give me an opportunity to explore some new features or something that I didn't cover, perhaps. You don't have to have covered it in the class for you to write about it. You might want to explore something that, I don't know, that it sparks your interest. That maybe you're working at a company that's doing something. You could write about that. Well, don't give away any trade secrets or anything, but you can certainly elaborate on something that interests you in the area. And this is completely written, which means you can include source code snippets if you want. Like, this is how you do this, and that's how you do that. But I want it primarily, more than 60% of it, or 60% of it needs to be words, 40% source code and pictures. So 60%, so more than half of it has to be words. Because I can see where the whole thing could end up being a picture here, source code here, source code there, picture here, and no words. It is supposed to be a writing assignment to help you practice your writing, because you're all graduate students and you're supposed to learn how to write, or you're supposed to be good writers when you graduate. So that's the purpose of this. It's an essay. So hopefully it'll look like an essay when you're done with it. So, and that gets uploaded into the ITU EMS along with everything else. And I believe within the next week we should have all that stuff ready to go in the EMS. If it's not ready to go already, we should have spots for you to upload that. So, questions, comments, concerns about anything? Nope. Nothing. You guys all sign the attendance? Then we're done for today. Go home and start working on all these assignments. They'll be due before long. So. You got tons of work I just gave you. It's not too bad, though. Uh-oh, what happened?